Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. In today's lecture, we will cover the coordinate geometry and we will talk about section formula. Right? In the previous lecture, we spoke about the distance formula and the applications of distance formula. Right? So in this section, we will cover the section formula. What is section formula? Let us say there is a line segment and a point cuts this line segment into two parts, right? Let's say in a ratio m1 is to m2. Now we will have to find the coordinates of this point, right? Let us say there is this line AB, okay? There is this point P which cuts this line in a ratio m1 is to m2, right? So AP is to PB is equal to m1 is to m2, right? And coordinates of A and B are given. Let's say x1 y1 x2 y2. Now you are supposed to find the coordinates of point P when it is given that it divides this line segment into a ratio m1 is to m2, right? Otherwise, second type of questions can be that you are given the coordinates of point P also. Okay, let us say you are given the point coordinates of point A, coordinates of point B and coordinates of point P also, and now you are asked to find this ratio AP is to PB, right? So this is the basic idea behind this exercise. Let us first of all see if this is our rectangular axis, right? This is the x-axis, this is y-axis, y dash, and this is x dash, right? Let us say this is the line AB, okay? This is point A, this is point B. Coordinates of point A are x1 y1 and point B x2 y2, right? Let us take a point P here. Now we know that this point P divides this line segment into a ratio m1 is to m2, m1 is to m2. Now we need to find the coordinates of point P in terms of coordinates of A and coordinates of B, right? These are the given quantities, right? Coordinates of A and B are given. So we need to find the coordinates of P in terms of the given things. For the time being, let's assume the coordinates as x comma y, right? So now if I ask you what will be this point is obviously x1 comma 0, right? So if I ask you what is the length of this segment is x1, right? Similarly, if I drop a perpendicular from point P on x-axis and from B to the x-axis, what will be the coordinates of this point? X comma 0 and this point x2 comma 0, right? And if I drop a perpendicular on the y-axis, so what will be the coordinates of this point? 0 comma y1 and this point, this is a perpendicular line, right? So this point is 0 comma y, and if you extend this and drop a perpendicular from B, this point is 0 comma y2, right? This is the basic thing that we have covered in first lecture, that if this is a point A in two-dimensional coordinate system, then this first coordinate, which is an x coordinate, gives you the length on x-axis, right? So how much you have to travel in a horizontal direction, right? So if I ask you how much is this distance is x, right? And how much is this is x2. Similarly, on the y-axis, this distance is y1, this much is y, and this distance is y2, right? So now if I make triangles like these, let me draw these parallel lines. This is parallel to x-axis, right? And these lines are parallel to y-axis. So obviously this angle will be 90 degrees, right? And also this line AB, let us say there is this line, okay? If I draw two parallel lines like this, these angles will be equal, right? Why? Because these are the corresponding angles, right? So these angles will be equal, hence we can say that this angle is equal to this angle, right? So the third angle will also be equal. If two angles of a triangle of two different triangles are equal, then the third angle has to be equal, right? So as per the angle similarity criterion, these two triangles are similar to each other, right? If two angles of two triangles are equal, then these triangles are similar, right? This is the similarity criterion which you studied in the previous chapter, right? So these two triangles are similar, and let's talk about the sides of these triangles. This side is how much? X minus x1, right? This distance x minus this distance x1 will give you this distance, right? So this is x minus x1, and this one is x2 minus x, right? And on the y-axis, this side will be how much? Y minus y1, and this side will be y2 minus y, right? How did I get these sides? Just by subtracting these distances, right? So now we know the sides of these triangles, right? So as per the similarity criterion, I can say the ratios of these sides is equal. So I can say that x minus x1 divided by x2 minus x is equal to m1 divided by m2, right? Because ratio of side AP and side PB is m1 is to m2, right? So these ratios have to be equal. Okay, so let us say this is our first equation. Now if you cross multiply, then m2x minus m2x1 will be equal to m1x2 minus m1x, right? Okay, so I've just cross multiplied. So now what I'll do is I'll collect the terms in x on one side. So m2x plus m1x is equal to m1x2 plus m2x1, right? So if I take x common and take the m1 plus m2 on the other side, so it will give me m1x2 plus m2x1 divided by m1 plus m2, right? So what have we done here? We have calculated the x coordinate of point P, right, in terms of the known quantities, known coordinates x1, x2, m1, m2, all these are known to us, right? And we have got the x coordinate of point P. Now we have to find the y coordinate of point P. How do we find the y coordinate? By taking the ratio of these sides, y minus y1 divided by this side divided by this side, y2 minus y will also be equal to m1 by m2, right? m1 by m2, right? So let's cross multiply m2y minus m2y1. This is the similar pattern, so I'll get the similar answer, just y1 in place of x1 and y2 in place of x2, right? So let's calculate m1 y2 minus m1 y. So take all the terms in y on one side, so m1 y plus m2 y will be equal to m1 y2 plus m2 y1, right? So now if I take y common, it will give me m1 y2 plus m2 y1, hence we can say y is equal to m1 y2 plus m2 y1 divided by m1 plus m2, right? So what we can say here, that coordinates of point P are, x coordinate was m1 x2 plus m2 x1 divided by m1 plus m2, and what was the y coordinate? This one, m1 y2 plus m2 y1 divided by m1 plus m2, right? So this is the point that we have got. This point divides the line segment AB in ratio m1 is to m2, right? Okay, so if let us say there is this point P and this is AB line segment, right? If in a special case this P bisects this line segment AB, what will happen? These two segments will be equal. So what will be the ratio in which P is dividing this line segment? 1 is to 1, right? In this case M1 equal to M2, both are equal to 1, right? Or we can say M1 is equal to M2, right? So the ratio is equal. We can say 2 is to 2, 3 is to 3, or 1 is to 1. It is one and the same thing. So point P is bisecting this line segment AB. So in this case M1 is equal to M2. So the coordinates of midpoint of line segment AB will be equal to, just replace M2 by M1 or M1 by M2. So what will happen is M1 x2, I am replacing M2 by M1, right? M1 plus M1, right? So let's talk about x coordinate only, because y coordinate will also behave like the x coordinate, because these two are symmetric, right? Symmetric terms. So in this, if I take M1 as common, it will give me x1 plus x2 inside divided by 2m1. So m1 gets cancelled. So the x coordinate is x1 plus x2 by 2. And similarly, we can say the y coordinate will be y1 plus y2 by 2. So coordinates of midpoint are midpoint of A, where A was x1 y1, and B x2 y2, midpoint of the line segment AB, where A and B are these, is equal to x1 plus x2 by 2, comma y1 plus y2 by 2. So these are the coordinates of the midpoint. We have just added the x coordinates and divided by 2, added the y coordinates and divided by 2. So these are the coordinates of the midpoint of this line segment, right? So this is the section formula. And what else we can do in section formula? See, let us say we are dividing a line segment AB in a ratio m1 is to m2, right? Another way of saying this thing will be, if I say m1 is to m2, right, I can say m1 by m2 is to 1 also, right? This is the same ratio as this one, right? If I say a ratio is 2 is to 3, I can also say 2 by 3 is to 1. So this is the same ratio as this one, right? So while assuming the ratio, we can assume the ratio as k is to 1 always, right? And then let us say if we get the value of k as 2 by 3, then we can say the ratio is 2 is to 3, right? When k is to 1 is assumed as my ratio, and k I have got as 2 by 3. So the final ratio is 2 by 3 is to 1, which is nothing but 2 is to 3, right? So just to simplify the question, rather than assuming m1 is to m2, we can always assume k is to 1. And then finally when we get the value of k, we can write the ratio like this, right?